Okay, students, today we are discussing a very new topic here. So we shall discuss about that topic in details here. So what is going to happen in this? Let us go one by one. So now, first of all, let us consider there is one block which is hanging. Okay, and when the block is hanging, and if you observe, this block is at rest. What I am going to say is, this block is at rest now, and this block is moving upward with certain acceleration here, and this block is moving down with certain acceleration here. In these three cases, what is the difference? So if you observe here, as the block is at rest, tension upwards will be equal to weight downwards. So the block is going to be balanced. It is an equilibrium. The upward forces are equal to downward forces. So we will write tension is equal to mg. Okay, so here, as the block is not at all moving here, it is at rest. As it is at rest, T is going to become mg. As it is at rest, T is going to become mg. But if you observe this block is moving upwards. This block is moving upwards. What does it mean? Here, two forces are acting. Then also block is moving upwards. What does it mean? That means T dominates. T dominates mg. As T dominates mg, resultant force is going to become T minus mg. Resultant force is going to become T minus mg. And what is the resultant force? Resultant force is equal to ma is equal to T minus mg. Therefore, T is equal to m into g plus a. T is equal to m into g plus a as the body is moving up. So with this you will understand that tension when the block is moving upwards is m into g plus a. This mg goes to left side. So this is the formula here. Now let us consider what happens when the block moves down with an acceleration. What happens when the block moves down with an acceleration? Here two forces are acting, tension and mg. Oh, though the two forces are acting, tension and mg, the block is moving downwards. That means a resultant force is also acting downwards. Here resultant force was acting upwards. Always resultant force will be towards the dominating side. Always resulting force will be towards the dominating force. As an acceleration is directly proportional to force, both are having same direction. Now what is going to dominate here? Mg is going to dominate here. Mg is going to dominate tension here. As Mg is going to dominate tension here, a resultant force will become mg minus tension, and resultant force according to Newton's second law is ma, which is equal to mg minus tension T. So tension goes to left side, mg is here only minus ma. Therefore T is equal to m into g minus a. T is equal to m into g minus a. And what is this T? This is tension when the block is moving down. These formulas you have to remember here. These formulas are very important, and definitely you have to remember these formulas. The first thing is, when the block is at rest, tension is going to become equal to mg. When the block is moving upwards, tension is going to become m into g plus a. And when the block is moving downwards, tension will become m into g minus a. Okay, so if you understand these three basic concepts, then you can understand whatever I am going to discuss now. So now let us solve this problem here. He is asking us to find out an acceleration a and tension t in the figure below. So how are you going to find out an acceleration a and tension t in the figure below? If you observe, 100 newtons are acting upwards. So these two blocks are moving upward with an acceleration a. As these two blocks are moving upward with an acceleration a here, let us see what is going to happen. For that you have to consider a free body diagram now. First, let us consider free body diagram now. So free body diagram of mass m1. So if you observe here, this is m1 is 2 kg. Let us write a general formula now. This is a mass of m1 in which 100 newtons, that is F, is acting upwards. So this is equal to F here. So general formula I will derive. After that I will solve the problem. So what is acting downwards? Downwards, your M1G is acting downwards. Even tension is also acting downwards. F is acting upwards. M1G is acting downwards. Tension is also acting downwards. All these things are acting on this, but acceleration is going to act upwards. That means resultant force is also going to become upwards here. So if this is the case, let us write the formula for this. So when both the forces are acting, then also block is moving upwards. When both the forces are acting, then also block is moving upwards. That means upward force is dominating downward force. So what are you going to write now? Resultant force Fr is going to become capital F minus m1 into g minus tension T. So because this is m1g plus T, so minus it is there, so m1 into g plus tension T. If you want, you can write in brackets and just simplify here. Minus is there, that's why this is also going to become minus here. So what is the resultant force here? It can be considered as m1 into A F1 minus m1 into g minus tension T. So this is going to be free body diagram equation for the first body. Next, let us draw the free body diagram for the second body. So free body diagram for mass m2. So if you observe mass m2 here, this is going to be mass m2. So how many forces are acting on mass m2? If I am going to consider this is a mass of m2, okay, that is a lower body, then how many forces are acting on this body here? So you know that m2 into g is acting downwards and tension is acting upwards, acceleration is acting upwards, resultant force is also acting upwards, resultant force is also acting upwards. Then when both the forces are acting, then also block is moving upwards, means upward force is dominating downward force, upward force is dominating downward force. Then the equation you are going to write, is resultant force will become difference of these two, that is T minus m2 into g. Therefore Fr is going to become m2 into A, which is T minus m2 into g here. Okay, so this is considered as equation number 1. This is considered as equation number 2 here. Let us imagine what is going to happen. So let me write this in brackets, this in box here, and this is going to be equation number 1 here. This also I am writing in box here. This is going to become equation number 2 here. So what are you going to do then? Then add them. Add these two equations. Add 1 and 2. Then if you add 1 and 2, what is the final equation you are getting? So if you add LHS first, so m1 plus m2 into A. So you are adding LHS. Then RHS, T minus m2 into G plus F minus m1 into G minus tension T. So if you have added all these three, then what are you going to get? You just cancel out these two. You just cancel out these two. Then what are you going to get here? So acceleration you have to find out. The final formula is acceleration is equal to here F minus m1g minus m2g whole divided by m1 plus m2 whole divided by m1 plus m2. So we got the formula for acceleration. So once you get a formula for acceleration, then this formula, if you substitute either in 2 or in 1, you are going to get the answer. Okay, so first let us find out acceleration by substituting the values here. Whatever the values we have been given in this problem, let us substitute and get the values here. So let me write the formula once again. F minus m1 into g minus m2 into g whole divided by m1 plus m2. So F is going to become 200 newtons and m1 is going to become 2 kg and m2 is going to become 3 kg. Let us consider g as a 10 here. Okay, so if you substitute all the values according to the question given here, so what is the answer you are going to get? What is the answer you are going to get? Let us see. So acceleration is equal to F is nothing but 100 newtons. 100 newtons, isn't it? Yes, 100. Yes, 100 is given. I'm sorry, 100 is given here according to the problem. F is going to be 100 newtons. So if F is going to be 100 newtons, just substitute 100 newtons, and this is m1, 2 into g, that is 20, and 3 into g, that is 30. So therefore divided by m1 plus m2 is going to be 5. So acceleration is going to become 100 minus 50 by 5. So this is going to be 50 by 5. This implies that acceleration is going to become 10 meter per second square. So you got a formula for acceleration. You got an answer for acceleration. So once you get a formula for acceleration, can't you find out tension? You can substitute either in equation number 1 or equation number 2. But do the wise work. Do the wise work. Decrease your work and increase the productivity. So this is a complex equation. It is a foolishness that if you substitute here, it takes a lot of time. Let us substitute in equation number 2. Let us substitute in equation number 2 and get the answer. Get the answer here. So m2 into a. So your aim is to find out what is t here. So from this you do one thing. So let us take t separately and write m2. m2 is equal to this comes left side becomes plus m2g plus m2a. So m2 you can common out and write mg plus a. So this is t up is equal to g plus a. I already have discussed about this in the previous page. That is tension upward is equal to m2 into g plus a. It's very simple now. So tension upwards is equal to, what is m2 here? m2 is 3, g is 10, acceleration is again 10. So tension upwards is equal to 10 plus 10 is going to be 20. So 3 into 20. So tension upwards, 3 2s are 6, that is 60 newtons. Got the point? It's very simple. So you got the answer for even acceleration also. So we got the answer for even acceleration also, that is 10 meter per second square, and we got an answer for tension also, which is 60 newtons.